Hello, we are discussing about GATE 1997 ECE paper, and this question is related to digital circuits. Look at the circuit diagram. The circuit diagram is related to a sequence generator, and the counter status Q0, Q1, Q2 is initialized to 0, 1, 0 using preset or clear inputs. The clock has a period of 50 nanoseconds, and transitions take place at the rising clock edge. So we are going to solve the sequence generates at Q0 until it is going to be repeating, and what is the repetition rate of the generated sequence. These two things we are going to calculate. This is a 5 mark question, came in GATE 1997. Okay. So for this diagram, first of all we should know about this is using the D flip-flops. So output of D flip-flop, that is nothing but next state of D flip-flop is nothing but the input present at that instant. We know that one for D flip-flop. For D flip-flop, that is nothing but delay flip-flop. Next state Qn plus 1 is going to be treated as D. The data present at that input is going to be available at the output after the clock edge occurs. Okay, so whatever the data is present at the input, that will be the output after clock edge. That's why only the data is going to be getting delayed by one clock pulse. So because of this one, the name D implies nothing but delay. Delay flip-flop has come. Okay, so based on this one, if you are going to write the sequence for this one, let us assume we are going for the present state and next state sequence. Present state and next state sequence we are going with, and the initial state is nothing but given. Initial state is nothing but Q0, Q1, Q2, Q0, Q1, Q2, which is going to be given as 0, 1, 0. It has been initialized to 0, 1, 0. This sequence generator is initialized to 0, 1, 0 using preset and clear inputs. And next state implies nothing but it is going to be treated as Q2 plus Q1 plus and Q0 plus Q1 plus and Q2 plus. That implies nothing but next state of Q0 flip flop is nothing but D0. Next state of Q1 flip flop is D1. Next state of Q2 flip flop is nothing but D2. So we must solve what is meant by D1, D2. Okay, so if you observe D0, you are going to be getting the connection for D0 is given from Q2 bar. So D0 is equal to, okay, look at this one, D0 is equal to Q2 bar. D0 is Q2 bar, and D1 is equal to Q0 bar, and D2 is equal to multiplication of, this is AND gate, so logical multiplication of Q1 bar and Q0. So this is going to be treated as Q1 D2 is equal to Q1 bar into Q0. So this is what the D2, D1, D0 flip-flops. So based on the present state, you can write the D0, D1, D2. That implies nothing but that will be the next state after application of clock edge. So we can consider that as next state. Okay. So now D0 implies nothing but D0 is Q2 bar. Q2 is 0, so that Q2 bar is 1. D1 is Q0 bar. Q0 bar is nothing but 1. D2 is Q1 bar into Q0, so it will be 0. So 110 is going to be the next state. 110 is next state. Whenever 110 is present state, what will be the next state? The next state is going to be D0 is Q2 bar. Q2 is 0, so that you will get it as 1. Okay. Next D1 is Q0 bar, so it will be 1 bar is nothing but 0. D2 is Q0 into Q1 bar. Q0 into Q1 bar. Q1 is 1, so that you will get it as 0. 1 bar is, so 100 you will get. Now 100 is going to be the present state. For this 100, if you use, you are going to be getting the 101 state. For 101 state, okay, by using the equations of D0, D1, D2, you are going to be getting 001 is going to be the next state. For 001, you are going to be getting the next state as 010, and 010 implies nothing but here you are going to be getting, that is from this one the sequence repeats. So from this one sequence repeats. because 0 1 0 is going to be the initial state. So this is going to be the states it is going through: 0 1 0, 1 1 0, 1 0 0, 1 0 1, 0 0 1, and again it is going to be repeating from 0 1 0 onwards. So the sequence present at q naught, give the sequence generates at q naught till it is repeating. So the answer for this one is equal to, till q naught it is repeating, it is starting with 0 1 1 1 0. This is what the sequence, and afterwards it is going to be, again it is repeating, again it is 0 1 1 1 0, like this it is repeating the sequence. Okay, so that implies nothing but after every 5 clock pulses the counter is repeating. After every 5 clock pulses the sequence is going to be repeating. Okay, you can think in this way. Now we are going for the second bit. Okay, so sequence repeats, sequence repeats after every 5 clock cycles, every 5 clock cycles. So that implies nothing but repetition is going to be taking place after 5 clock pulses is nothing but duration. Okay, between repetition is nothing but 5 times of t, that is nothing but 5 into 50 nanoseconds. 5 into 50 is nothing but 250 nanoseconds. 250 nanoseconds is going to be the delay between the repetitions. So repetition rate is nothing but repetition rate, repetition rate is, repetition rate is 1 by 5t, which is nothing but 1 by 250, 1 by 250 nanoseconds, which implies nothing but 4 megahertz. So this is going to be treated as 4 megahertz is going to be the repetition rate. Repetition rate is nothing but at what rate the sequence is going to be repeating. Sequence is repeating after every 250 nanoseconds. The frequency is nothing but reciprocal of that one. Repetition rate is reciprocal of 250 nanoseconds, which is nothing but 4 megahertz. Okay, so the sequence generating at q naught is 0 1 1 1 0 and the repetition rate is 4 megahertz for the given question. Thank you.